Hi, it's Peter Rossi again to talk to you a little bit about data types in R. So first, we have encountered two already, the data frame and the numeric vector. So very briefly, let's look at what numeric vectors are. Here I'm going to create a numeric vector called num, and I'm simply going to put the sequence from 1 to 10 in it. Okay. And so if I just type num or display num, you can see those sequences. As we know, we can index into num by using the square bracket notation. And the 3 would give me the third element. And what is the square bracket? It's actually a function that says, please access the num vector and give me whatever the specified value, index value is. As you know, we can also use logical expressions like please give me all the num values such that the num is greater than 5, which will only give me the last 5 values of the vector. Okay. Now what is a vector? A vector is a list that's indexable, and it's a list of things that have all the same type. So in this case, it's an example of a list of numbers. R does not really distinguish between integers and floating point numbers. It treats them the same. So there's no difference between 1 and 1.0 or 1.0 times 10 to the first power, or 10, or so on. So it doesn't really make those distinctions. Some other languages do, but not R. Okay, the other type of vector that's used frequently is a character vector, namely a vector whose elements are strings or text elements, right? And here I'm going to create one called date. And what is in date? Date is just these strings which refer to actually the first 3 days of 2013 in the format YYY-MM-DD. Okay, but R doesn't know that those are dates. It just says this is a character vector. So if I say structure date, it says character of 3, and it gives some of the representative elements. Okay, now for some purposes, I would like R to recognize that these are actually valid dates. And I can convert it to another type of vector called, they call it in R a class, using the as capital date function of date. And R date now, if I look at what it is a date vector. So it's actually read these things in, and it understands this identifies a particular month, year, and day. So for example, if I use the plot function and plot R date versus some arbitrary set of numbers, 1 through 3, it'll actually understand that these are days of the week, and it plots over here, and you can see along the x-axis or horizontal axis, these refer to these days. So the first 3 days of 2013 were Tuesday, Wednesday, and Thursday. Okay, so that's a character vector. All right, now one other thing, that is certainly one very useful thing, but most people want to rearrange vectors in a array. An array is something of 2 or higher dimensions that can be indexed by its subscripts that correspond to each dimension. Right? So we're all familiar with the data frame or spreadsheet in which there are 2 dimensions, a row and column dimension. The row typically corresponding to the observations and the column corresponding to variables. Okay. So let's make an array out of that num vector. So here I've given it the command matrix as a function, says please take num and make an array out of it with 2 columns. Now what kind of array will come out of it? Well, there's only 10 elements in num. So when I execute that command, it's going to be an array that has 5 rows and 2 columns. And it will take the vector num and paint it into the array, going column by column, going down the first column, then the second column, and on until it exhausts the vector num. Right? So it's going to paint it down the first column, 1, 2, 3, 4, 5, 6 through 10. This says the row subscript is varying faster than the column subscript. That's how some people say it. R has this interesting feature that if I tell it to make an array or a matrix that has more elements in it than the vector that I'm using to fill it out, it will actually repeat the vector until it has enough elements. So this is now a 5 by 4 array with 20 elements in it, and it's going to take that same vector 1 through 10 and paint it down itself twice. Okay, that's a feature of R. Okay, now you can have a 3-dimensional array. So suppose you had data like the prices of different products at different retailers in different locations, right? So I had say, the price of the Apple product line in a retailer like Best Buy or something in Westwood versus the Apple Store in Century City, I would have a three-dimensional array. The first array subscript might refer to which product, iPad, iTouch, iPhone. The second might refer to which retailer, Best Buy, Apple Store, etc. The third might refer to location, like neighborhoods within LA or states of the union or what have you. Okay, so that would be use of three-dimensional arrays. So lots of complex data can be viewed as stored rather as a three-dimensional array. Okay, so we have encountered a very special type of array, or at least that's something that acts functionally like an array, namely the data frame. So let's review that. Let's bring in the flat panel television right here and attach it. Okay, I've already done that. So what is that structure? Flat. Okay, it's a data frame. So at least in one sense, it behaves like an array, right? Namely, it's got 70 observations and 5 variables. Rows corresponding to observations, columns corresponding to variables, and we can treat it and index it just exactly like an array. So if I say the square bracket 1, 1, that's going to be the first variable, which is price, the first observation, which is $1,527. Okay, I can also access the second variable, first observation, which is the size of that particular model, which is a 46-inch. Okay. But as we've seen, we can also access elements of a data frame by their variable name. So obviously if we say price, I've attached it so I don't need to say flat panel dollar price. I get all the price values and so on. Okay. One final observation, unlike a matrix or standard array, a data frame can have a mixture of different types of variables. The first two variables or first two columns correspond to numeric variables. The other variables correspond to categorical variables, a very special type of variable called a factor. So it says brand is a factor with 3 levels, and it gives some of the levels, and it actually codes it as numbers, right? So if we say brand, it's basically, will print out or display the values that brand takes on, right, which are the values of Samsung, LG, and Panasonic. If we say levels of brand, that will give you the unique values in it. So there's only got 3 unique brands in that vector. Okay, so that factor idea is utilized by lots of our functions. We've already seen that LM utilize it. We can also use it to do things like run a regression for every separate value of a factor. So we have a very big data set that has different regions of the country, and we wanted to run a regression for each region separately. I'll show you later in the class how we could do that using a factor as a way of indexing the data set. Okay. So it's a general way of indexing the data set. Okay. Now let me convert this flat panel television set into a matrix just to show you that that can be done. So I've done it here as matrix of flat panel. So let's run that. And what is in, let's type the head of mat FP. And what it is now, it is a structure. It is that a character array. So what matrices can only contain elements of the same type, right? And this is a weird thing here that contains a mixture of strings and numbers. So it says, I'm sorry, I can't deal with that. I'm going to convert everything into a string. Okay. If I want to convert something back from a string to a number, I just say as numeric. So if I as numeric of mat FP of 1 will convert all those prices back into numbers. Okay. Okay. So that's a little bit about factors and arrays. The final thing we have is something called a list. And let me rerun the regression of price on size and type. Okay, and that's going to, what is in out? Out is the output of that regression procedure. And what kind of structure is it? Structure out. And it's going to give me a lot of output. So let me enlarge this window here. And it's got all kinds of things, but it says it's a list of 13 things. So out itself is a special type of vector called a list. And unlike character and numeric vectors and arrays, it can be a mixture of different types. So the first thing in out are the coefficients, and it is a numerical vector. Other things in it are actually a list themselves. So let's look at the first element of out. Okay, and we can refer to that either by the $ convention, right? And notice I didn't have to specify coefficients entirely, just uniquely, and it gives you the coefficients. Or I can use what are called a special indexing operator for lists, which are double square brackets. And they, of course, get the same thing. Okay. Now it's a mixture of things. There's a element in there called QR, which itself is a list. So just to give you an idea that you can embed or nest lists. You can have a list of lists of lists. So this is a list here. Out is a list of 13 elements. They can be referred to by their names, such as coefficients, residuals, etc. Or they can refer by their position, 1, 2, 3, 4, 5, 6, 7. And then what is in QR? QR is itself a list. And QR is a matrix decomposition utilized in the computation of the regression. So just for fun, let's look at what QR out, let's say structure, out $QR, out $QR, it's now a list of 5 things. The first thing of which is itself also called QR. It's a QR. That's a little confusing, I understand. But it's the element QR of the list called QR, and it appears to be a numerical array of 70 observations in three columns. Okay, so let's just do head of it. So head out $QR. $QR is the top of that array. Okay, so you can see that's actually an array. Okay, I could also specify this if this is a little confusing with the double bracket. So here I'm going to fetch the QR element of the out list and the first element of that, which again is this array. Okay, so hopefully that gives you a feeling for the different data types that are in R, adding to your repertoire of vectors, also the notion of a list, and almost all functions in R return lists. So the lm command returns a list, and then the other functions like summary or predict utilize that list to calculate other things. So that's a kind of very standard thing. So you need to know a little bit about the list type of data. You can see it's a very flexible type of vector. So I hope everyone has fun learning a little bit more about R and the interstices of R, if you will. And we will be back with you soon to talk about other features of R on a future video.